I'm Anil Kumar. Welcome to my series on fractions. We'll take up some amazing facts about fractions in this particular video. The question here is, how do we explain all these things? So I have a couple of things which always confuses us. The very first one is, circle sliced horizontally does not represent a fraction. What I'm trying to say here is that if I have a circle and if I cut it into 4 parts, then can I say this is 1/4, this is 1/4, this is 1/4, and this is 1/4? Or if I have a hexagon and if I divide it into 4 parts, can I say this is 1/4, this is 1/4, this is 1/4, and this is 1/4? That is the question, right? So in both these cases, is it true or false? Right? That is what we'll think about. And why? The answer is that it is false. So a circle sliced horizontally does not represent a fraction for sure. But why? That is what we want to understand. Okay? The second one is, when you increase the denominator, value of fraction decreases. When you increase the numerator, the fraction may become improper fraction. Well, it is a fraction. We are only increasing the value of the numerator. Why does it become improper fraction? We'll look into this. And then, you can't add denominators even if the numerators are equal. Normally, when denominators are equal, you add numerators, but you can't do the reverse. Why? And the last question here is that there are infinite fractions between any two fractions. For example, if I write 2/7 and let's say 3/7, then in between there are many fractions. Is it true? We are going to answer all these questions in this particular video. Okay? I hope that's interesting. So let's begin with the circle. Circle sliced horizontally does not represent a function. It really means that if I slice with lines which are equally spaced, right, even if my lines are equally spaced, that means to say, if this distance, let us say, are all equal, right? So this is 1/4, this is 1/4, this is 1/4, this is 1/4. Even then, inside, the fraction is not 1/4. This and this are not 1/4. Why? That is the question. So the important thing to understand in fractions is that fraction we need to divide in equal parts. So whenever we talk about fractions, we need to divide in equal parts. What do you notice in this case? Are these parts or slices equal? I don't think so. So here, all of them are of different size. Since they are different size, we cannot say they represent part of the whole. So to make it part of the whole, we have to have equal parts, right? That is important. So as you can clearly see here, since they are not equal parts, these cannot represent a fraction. Clear? So if I have to make a fraction, what should I do? Well, in that case, as far as the circle is concerned, we have to divide it kind of like this. Go via the diameter. So this is the diameter 1 and that is the diameter. So then we say, if these are the two diameters, these are 1/4, 1 out of 4. Do you see that? Now we have all equal parts. Correct? So that is okay. That is correct. But this is not fine. Perfect. So I hope you get the concept. Whenever we talk about fractions, it is part of whole and whole divided in equal parts. Is that clear? Correct? Only then it is a fraction, otherwise that slice does not represent a fraction of the whole. Is that okay? Right. Now let's look into the second concept, which is when you increase denominator, value of fraction decreases. So that is interesting. What we will do here is that we'll begin with one rectangle and this is one whole, right? So what we have here is just one whole. And if I divide equally, let us say from the center, then what have we done? We have got two divisions, right? So when we say one whole, in that case the denominator is 1 over 1, correct? Now, if I divide it into two parts, then it becomes 1 over 2. Do you see that? So when you increase the denominator, so when you increase this is the denominator, right? So when you increase this from 1 to 2, it decreases. You can see it becomes half. Does it make sense to you? It decreases. So you can see that we have more the parts we have, we'll write equal parts. More the number of equal parts, less is value of each individual part, right? So 1 over 2 becomes much lesser than 1. If I divide it further into equal parts, then this portion will be 1/4. So if I divide it further by 2, now you can see 1/4 is only that much. It is half of half, right? It is half of half. So you can clearly see that when we divide or when we increase the denominator, in that case the fraction value decreases, right? So let's be very clear about it. So fraction basically has a numerator and the bottom part is the denominator. So if we increase denominator, it becomes lesser. It means what? Here we have a circle divided into 1, 2, 3, 4, 5, 6, 7, 8 parts. So each part is 1/8, correct? Now, if I divide it further, do you see that? Then what happens to this part? I have done half of 1/8. So this part is much smaller. You can compare. It is half of the original. It is 1/16. So the denominator increased from 8 to 16 and our slice reduced to half of original. Do you see that part? So you understand now that when you increase the denominator, value of the fraction decreases. Okay, clear? Let's see the next concept, and that is when you increase the numerator, the fraction may become improper fraction. Okay, how do we explain this? So let's have some figures here. So let's shade two of them. Okay, so at present I shaded two of them. So the portion which is shaded is, we got 2 units, right? 2. Out of 1, 2, 3, 4, 5, 6. So 2 over 6 is shaded portion. Correct? Now they are saying when you increase the numerator, the fraction may become improper fraction. So let us increase this 2 and add 5 to it. So if I do 2 plus 5, then what happens? denominator still being 6, what you get here is 7 over 6. Now 7 over 6 is improper fraction. Why? This is improper fraction. Because numerator this is greater than denominator. 7 is greater than 6. Do you get the idea? So, So you see that when numerator is increased without changing the denominator, then it may become improper fraction. Perfect? 7 over 6. Now if I have to show 7 over 6 improper fraction, how do I show it? Well, 7 over 6 is like 6 plus 1 over 6 over 6. Now 6 over 6 is 1 whole plus 1 over 6. This is what 7 over 6 is equal to. So what I can do here is, I already had 2, I added 5. So that means I added 1, then the second one, then I added the third one, and then I added the fourth one. What should I do with the fifth one? I have to get into a new one. Do you see that? So this is improper. Now I'm not talking about just one hexagon. I have 2 involved. This is 1 whole. This is my 1 whole, correct? And this one here is what? Is 1 out of 6. Do you understand? So, when we increase the numerator, a fraction may become improper fraction, and to show that, we may use more than 1 whole, like this. So I hope you're getting the concept, right? So we'll talk about these things later in details, but now the interesting fact about this is that numerator increased may cause fraction to become improper fraction. Then it is like one number plus fraction, right? We call this as a mixed number. This one, written as 1 over 6, will be turned as mixed number. Okay? Fine. So now, let's take the next part of our amazing facts about fractions. To add fractions, numerators of the fractions are added if they have the same denominator. For example, 4 over 15 plus 7 over 15 is, you add 4 and 7, you get 11, right? So what you do is you just add 4 and 7 and the denominator remains as 15 and you get your result as 11 over 15, correct? So that is how we add fractions. We need to have same denominator to add fractions. Perfect. Now the question comes that we need to explain why the denominators are not added when the fraction has the same numerator. For example, 3 over 5 plus 3 over 10. We see 3 and 3, same numerator, but we are not adding denominators. We don't add 5 and 10 to make it 3 over 15. This is wrong. The question here is why? We know this is wrong, but the question here is why. How do you explain it? How do we explain it? That is the major question which is going to be addressed in this particular video, right? So let's try to understand the concept and we'll get to this, why we are not adding the numerators, why we are not adding the denominators when the numerators are exactly same as in our case 3 over 5 plus 3 over 10. Well, think about it like this. When you add two positive numbers, then what happened? Then sum is greater than either both of them, right? Correct? So what I'm trying to say here is that the rule is that if I add something to 7, let's say 5, I get 12. We know 12 is greater than 7 and 12 is also greater than 5. Right? So when we add two positive numbers, we do get a sum which is always greater. Correct? So that's the rule. That is how our number system works. Perfect. Now see what happens. If I have 3 over 10 and 3 over 5, let me write 3 over 5 first, and 3 over 10. If you add the denominators, make it 15, 3 over 15, then what do you get? 3 over 15 is much, much smaller than both of them, right? So that gives you what? That gives you a number, 3 over 15 is smaller than 3 over 5, and 3 over 15 is also smaller than 3 over 10. Correct? Therefore, it is incorrect. Correct? So that is the idea. When you add, you expect a bigger number. But if you add the denominators, the number which you get will be 3 over 15. In this case, right? Whenever the denominator increases, the number value will decrease. Now that is not possible. When you add, you should get bigger answer, larger number. But here you get a smaller number, and therefore this is wrong. You get the idea, right? So that is the basis on which we can explain why denominators are not added if the numerators are same. Perfect. So what will you do to add them? We need to make their denominators same. Perfect. So what we will do here is we'll multiply both terms by 2 to make their denominators same. So we'll get 6 over 10 plus 3 over 10, and we'll add it to get 9 over 10. So that will be the correct answer. So the steps in adding always will be to make common denominator, then add numerator, which is this statement given here, right? So that is how we add. So we'll take up many examples in our series and understand how to efficiently add fractions with different denominators, and we'll also work with mixed numbers. I hope you find it interesting, and I hope you have also understood why denominators are never added. Perfect. When you add denominators, you will get a much smaller number, which will be wrong. I hope you understand and appreciate this concept. Okay, here is the last fact, and that is there are infinite fractions between any two fractions. This is the most important. How can you have infinite fractions between two small numbers? That is true. So we'll show you with the help of an example. So I'm taking two examples here, right? So let me say question 1 and then we'll do question 2. Question 1 for you is write a fraction between 5 over 11 and 6 over 11. Well, think about it. You can pause the video and answer. Now 5 and 6, there is nothing between them. What can I do? Well, from here, we can write equivalent fractions. You know how we can write equivalent fractions? We can times both numerator and denominator by the same number. So what I will do here is I will times both by 2. 2 over 2. That means I'll multiply numerator by 2, denominator by 2. If I do that, then 5 times 2 is 10. I get 10 over 22. And 6 times 2 is 12. 12 over 22. Do you see now I can insert a fraction here? 11 over 22. Do you see that? So I could get one fraction between these two, 5 over 11 and 6 over 11. And that is the trick. That is how I could write more fractions between any two fractions. I think you got it, right? So now, as an exercise, the question for you here is, write 3 fractions between 5 over 11 and 6 over 11. Right? I did one for you. You need to write 3. How can you do that? Think about it. Okay? What should you do? Well, since I have to write 3, last time I multiplied by 2, why not this time multiply by 4? Okay, so 4 times 5 is 20, so I get 20 over 44, and 4 times 6 is 24 over 44, correct? Do I get space for 3 fractions now in between? Well, we do. So here is one, then the next one, and then the third one. So 21 over 44 can go in between, 22 over 44 can go in between, and 23 over 44 can also go in between. Isn't that amazing? So that is how we work with fractions. I hope you find it very interesting and useful. So we began with these 5 amazing things, and we really found their solution, and we understood fairly well why. When you're slicing, it is not a fraction because we did not divide into equal parts, right? So to make it a fraction, we have to do equal parts. Now, each part in this case will be 1/6. Do you see that? And in the first case, what could I do? Well, I should have divided this kind of like this to get 1/4. Perfect? That is the whole thing. Second, when you increase denominator, value of the fraction decreases. Increasing denominator means dividing it further. Do you see that? That is denominator. Denominator is number of parts of the whole. That is, since denominator is parts of the whole. So if you increase, then the fraction decreases. Now third question was, when you increase numerator, the fraction may become improper. We did see that in the case of hexagon, when we increased, it became 7 over 6, right? And we saw how to represent that. And the next one was, you can't add denominators even if the numerators are equal, mainly because if you increase denominator, the fraction decreases, right? Fraction decreases, but add means more. You were expecting more, not less. Therefore, you cannot add denominators. Does it make sense to you? You can't add denominator because adding means more. But when you increase denominator, it becomes less. That is why you cannot do it. And then we found that with the help of equivalent fractions, we can insert as many fractions as you want. Perfect? If I multiply these by 10, so we get what? We get 20 over 70 and 30 over 70. You know, now we can have 9 fractions in between. So there is no limit. If I multiply by 100, then 99 fractions can be inserted. So that is how we work with fractions, and I hope these facts are absolutely clear. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Share my videos with your friends. Thank you.